Let's review the strategy of implementing working fluid pipelines with buffer storage wells throughout the Recovery 2.0 process. The Recovery 2.0 system is an innovative approach to manage the treatment of residual waste materials in a sustainable method by treating waste as a resource, while assisting with the world's demand for clean water and clean energy by using thermal reduction. The thermal reduction process includes a number of multi-stage processes that reduce mixed waste materials into basic elemental feedstocks. In order to maintain maximum flexibility in this step-by-step process, we chose to install a series of engineered buffer storage wells between each processing module. This method allows for temporary inventory reservoirs, and enables an automated dispatch system in order to control flow rates. Buffer storage wells installed with multiple plumbing pathway options ensure maximum flexibility in fluid routing options. Rapid route dispatching may avoid maintenance shutdowns by providing alternate pathway options that enable the process to flow on a continuous basis. Seamless swapping of dispatch pathways may optimize processes and production throughputs. Let's look at the function of an individual buffer storage well. The design of a buffer storage well acts as an expansion tank to accommodate the fluctuation of fluid flow between modules in the processing stages. This provides a layer of flow control, as opposed to inflexible direct flow systems. The working fluids, whether in a liquid or gas state, or in some combination of both, are collected in a temporary buffered space in between processing modules. This storage space is designed to compress or expand in order to accommodate the fluctuating fluid flow rates. So for example, the mixed hot gas hydrocarbons, in the form of a dirty syngas, may be accumulated as it exits the pyrolysis furnace, and staged for an orderly flow into the syngas oxidizing module. This allows for a managed control of continuous flow or batch flow rates as desired. The same flow control may be applied to each of the various stages of the water-steam pipeline, the CO2 pipeline, and the compressed air pipeline. The buffer storage wells, for the ancillary working fluid circuits, may act as a goods-in-process accumulator and a temporary inventory storage, as they await further processing. The buffer wells, used in the acid loops in the hydrometallurgy modules, aid in the concentration and selective extraction of a cascade of hundreds of elements. Energy harvesting opportunities. There are numerous locations across and throughout the Recovery 2.0 system, where buffer storage wells may be located, regardless of the type of working fluid contained in the particular well. With the use of dielectric elastomers, flexible bladders, or expandable piezoelectric membranes, we are able to take advantage of the fluctuation of expansion and contraction chamber actions, providing an opportunity for energy harvesting. Piezoelectric harvesters are considered a solid-state device that may convert the energy contained in fluid flows direct to electricity. With the combined movement of flows through the four main working fluid pipelines, along with the ancillary fluid circuit flows, the total volume of fluid movement may add up to be a meaningful energy source. Amplification of this harvestable energy source may be realized from the continuous repetitive flow of the regenerative loops, as it cycles around and around within the thermal reduction and recovery process. Whether fluids are flowing through smaller buffer storage wells, intermediate stages such as biolungs, or passing through larger storage reservoirs, the movement in and out of these working fluids results in a change in temperature, pressure, or volume, which generates continuous motion or an oscillation that may be harvested. The harvesting of energy from the fluid flow movements, as the mainstream thermal reduction process goals are achieved, is an example of a beneficial side stream and a bonus in the overall process. We intend to discuss additional facets of the energy and resource recovery sectors at some point in the future. Until then, please feel free to contact us at your convenience. Recovery 2.0 is a project developed by Waste.net, in an effort to reinforce our belief that as rational human beings, we must accept the ultimate responsibility to leave future generations with a safe and sound environment, and a world that has not been depleted of its resources. Please feel free to visit us today at www.waste.net.